Thanks again for coming today. My name's Alexis. I'm the biostatistician manager within CHOP's Data Science and Biostatistics unit. And today I'm going to be talking to you about data types and visualizations in R. Okay, so if just a little bit of information about these slides. So if you'd like to, you can either, of course, just follow along with the presentation here. But if you're interested in following along with the speaker notes, that's an option as well. And we're also going to have a few announcements just before we get started with today's material. For anyone here today who isn't already part of the CHOP R user group, I strongly encourage you to join. This group has more than 400 members in all departments and is a great way and a great place to network with other R users, to get help with coding problems, and learn about packages, webinars, and conferences. And this group also has semi-regular meetings and workshops similar to today's talk. And another option is, if you're looking for help with R, is to come to some of our R office hours. So we have regular office hours appointments where you can come and get R help. For these appointments, we have two options. So you can set up a one-on-one appointment if you would prefer to have individual help, or you can come to an open appointment, which are more of a community conversation about whatever R topics happen to be brought up for that particular day. There's a link to the calendar here where you can go ahead and book an appointment. And we'll also just mention that if this sounds like a really cool idea and you're an experienced R user who happens to be on today's call, definitely consider joining us and offering these appointments. You can schedule them for whatever times work for you, and that would be a great way. And so if you're interested in doing that, feel free to reach out to Rose. Her email is here and she can help you get set up. Okay. And so just a reminder that today's talk is the fourth in a new series called R102, Mastering the Fundamentals. And so these workshops are intended as a continuation of the popular Intro to R for Clinical Data workshop that is offered a few times a year. And we've designed these talks with the beginner in mind. So if you're trying to figure out how to get started with R or how to start applying R in your own work, hopefully these talks are geared for you. And if you're interested in seeing the schedule of talks, you can check out the website for our entire series. And I think it's been mentioned already, but that website will also have links to different slides and recordings as they become available. Okay, so our topic today is going to be data types and visualizations in R. So data visualizations are a key component of any exploratory data analysis. Today we'll also discuss how different variable types within R really can determine the visualizations that are possible. And as we're going through today's presentation, please feel free to put any questions in the chat. We have a few additional team members who will try to answer your questions during the talk. And if there's extra time, we can always stop and talk about things as a group. Okay, so here's a brief summary of what we're covering today. First, how to identify different data types in R. And then we'll kind of through this process review the data types that are available within R. We'll also talk about converting variables from one data type to another. And we'll also talk about creating flexible visualizations of our data in R. Okay, so first starting with identifying data types in R. There are several R functions that can return a variable's type. And for today's presentation, we're just going to be focusing on one of those functions, this str function, which displays the internal structure of an R object. And so that's how this function gets its name, from that structure word. Other options that can also return variable types include the class, function, and the type of function. And again, we won't go into a lot of detail with those today, but there is a link here where you can learn more about those if you're interested. Okay, so first we're going to start by talking about some of the more common data types. For example, one of the most common data types is the character data type. And for this data type, each value is a string. So for example, if you had the text word female, in a particular cell, that would be considered a character. And so here's a small example of what this might look like within R. So suppose you have an example or a vector called X, and each element within X is either the text, female or male. And then if we went to print this out, this is how it would look within R. And if we applied the str function to this variable X, you can see that it's returning that it's a character. Another very common data type within R is the factor data type. So this looks sort of similar to character vector in that each value is going to be stored as, each value is going to look as a string of text characters. However, the possible values are actually stored as levels within R. And we'll talk a little bit more about the difference between character and factor in a minute. And so again, we can look at a small example to see this. So if we take that X vector that we had created on the previous slide, we can actually see that you can see it looks a little bit different now, and that we have some additional text being printed out below, where R is telling us, there are actually levels, and the two levels in this case are female and male. And now if we apply the str function to our X vector as a factor, you can see that now we're getting some additional information. It actually says factor with two levels, female, male. So even though it maybe visually looks sort of similar to the character vector, R is treating this in a different way. Okay, the third very common data type that we'll see a lot in R is numeric data type, where each value is a real number. And so this is probably very familiar to everyone, but if you were to see a vector or input in a vector of numeric values, so here we have some negative values, a 0, and some positive values, and we were to look at that particular vector and apply the str function to that, you can see here that it is going to be returned as a numeric vector. And so I think those are probably the three most common data types, but we also wanted to mention that there are some other data types that are available in R that could be useful and do come up in certain applications. For example, another data type that actually could come up fairly often is a logical data type, where each value is either true or false. And here's a small example for that. And if you're not too familiar with this, it's also worth noting that R will actually treat true and capital T and false and capital F in a similar way. So you can see here, like in this particular example, this X vector is true, false, true, false. And when we look at applying the str function to this vector X, it's coming back as being logical. Another data type that's a little bit less common, but that is available within R, is the complex data type. And so for this data type, each value is a complex number. And again, this may only come up in really specific applications, but essentially by using, this little I within your numeric calculations, you can tell R that you want to be using complex numbers. And then when we apply the str function to this, it will be returned as complex. Okay, so and just a little bit more about the difference between character and factor data types, since these tend to look similar. So as we saw before, remember this when we printed this as a character vector, each element in the vector was returned with quotes. And then down here, when we print the same vector as a factor, we don't see the quotes anymore, and we do have this additional information about levels, saying female and male. So it's important to remember that factors are stored as numbers in a table of levels, and this can be really useful depending on your particular application because it can save memory and computation time. And it's also could be useful because more computational options are available for factors compared to characters. And one example of this was actually covered in one of our earlier talks with the summary function. So if you're interested in learning more about the summary function, feel free to check out the materials from our earlier talk, which are linked here. So of course, though, while there are some advantages and computational advantages of using factors, you definitely shouldn't feel like you need to convert every single character, column, or variable into a factor. Certain things where you don't really have any repetition, so maybe something like a patient name or a study ID, it's typically okay to continue to store those as character vectors. Okay. And just a quick aside that might be a kind of a question that's coming up for people is, can we mix data types? So let's see what happens when we try to store different data types within the same vector. So here's a small example that I put together where I'm trying to say, let X contain, these three elements. The first one being, a true indicator, the next one being 3.0, a numeric value, and the last one being a character vector that says male. And you can see when I try to print this out, actually right away, something kind of stands out where all three elements, true, 3, and male, are being printed out with quotes, which we know wouldn't really be the case if 3 was a numeric vector and wouldn't be the case if true was really being stored as logical. So when we apply the str function here, we can see that actually R is sort of converting all of these elements into characters. And so because of this sort of limitation, we generally want to avoid mixing data types within one variable or vector because R will try to convert all values in the column to one data type. And there's probably just very few applications where it would really make sense to have multiple data types within the same vector. Another question that might be coming up is, can we change data types? And the answer to this is definitely yes. So R has several built-in functions like as.factor, which actually we used on an earlier slide, if you saw when we were converting the numeric or the character vector into a factor vector. But then there are also functions as.character and as.numeric, which can be used. And so here are some just quick examples that are using those particular functions. So we can start, for example, with the vector of character text from before, and we can kind of, as we saw on one of the earlier slides, it can be very easy to convert that into a factor. And if you needed to, you can also convert that, just back into a character using the as.character function. And here's another example involving numeric data types. So for example, maybe you, for whatever reason, read in your numeric values in quotes, and you're seeing that R is treating these as a character. You can also use the as.numeric function to convert from character to numeric. Okay, so now that we've covered data types, we'll kind of switch gears and talk a little bit more about creating visualizations in R. And so how can we create visualizations in R? There are two general options for creating figures and visualizations in R. The first option would be to use the base R functions. So this might be a function like plot, if you're familiar with that. And the second option would be to use the tidyverse and functions like ggplot. And so I've included some links here to some galleries that have a lot of visualizations. You can see a lot of figures at these links that were created in base R, or in the second link, you can see that there'll be a lot of figures created with ggplot. And today we're going to first talk about some of the nice features of ggplot. And today's talk is going to focus on using ggplot. However, I encourage you to explore those previous links because I think you'll find that base R figures are also very flexible and they can be an equally good option when deciding on how to create visualizations in R. It may just depend on what type of figure you're trying to create and what sort of benefits you're looking for when creating those figures. But for today's talk, we're going to focus on using ggplot because they do have some nice features within ggplot that we'll talk about here. So for one, all of the figures are built using a series of layers, which can be very helpful in terms of flexibility or trying to troubleshoot, different problems when you're running into errors with plotting. Another great thing about ggplot is that you're able to save plots or partial plots as objects. And we'll go into more detail on this in a little bit, but just an example here where you can actually save sort of the basis of a plot as an object called P. And then kind of depending on what visualization you're interested in, you could either add points just by using P plus geom point, or you could, instead of adding points, decide you're going to add a line using P plus geom line. Another great thing about ggplot is that you can quickly create separate plots for each value of a factor variable using facet grid or facet wrap. And we'll be talking about both of these functions later on today as well. But again, just a reminder, base R figures can still be a really good option. It really could just depend on your particular application and the style of figure that appeals most to you. Okay, so for today's presentation, we're definitely going to try to get started with some coding because this is definitely one of the best ways to learn R and to practice. So we would definitely encourage you to work through the code yourself as you follow along. And to do this, there are two options. So option one, which we've been posting about in the chat a little bit earlier, which we would say might be the easiest option, would be to just click this particular link, and that will take you to a site where you'll be able to work in our Posit Cloud, and you'll be able to work with the code right in your own browser, and you won't need to install anything on your machine. You will need to have create a free account if you haven't already done so. But if you're interested, go ahead and click that link. It can take a minute or two to load. Or if you are more comfortable working on your own computer, you can also get all of the code for this talk directly from our GitHub, and then you can download it to work on your own machine. So if you want to go this route, click the second link and find the green code button, and then kind of you'll go through several options, one of which is downloading a zip file. And if you're going that route, we would recommend you try to work in RStudio. Okay, and I think I'll just give everybody a minute or two to get situated and find the environment. So if you are working in Posit Cloud, let me see, it should look something like this. Again, it might take a minute or two to load. Okay, and today, from the project directory, I would encourage you to go to exercises and then find the data types in viz exercises file. And you should be able to open that right in your web browser. Okay, we'll go ahead and keep going. But if you're having any trouble accessing either of the links here, feel free to reach out in the chat and we'll see if somebody can help you get set up. Oh, I'll see. Wait for people to thumbs up Rose's comment. Okay, we'll keep going. Okay, so here are the packages that we'll be using today. So we'll need to load the tidyverse packages since we'll be using several functions that come in the tidyverse. We'll also load the medical data package, which includes several publicly available data sets with medical data. And we'll also be using the ggplot2 package today for creating visualizations. And just a quick note here that the ggplot2 package is actually part of the tidyverse. You really don't technically need to install it or load it separately. However, it can be installed and loaded separately from the tidyverse. So these packages all have excellent websites that are available with a lot of great tutorials and such. So if you have time and you're interested, definitely feel free to come back and go to these links and look at the websites if you're interested in learning more. Okay, so if you're running the code today on your own computer rather than the POSIT cloud, you may need to run this install packages line if you haven't ever used these packages before. If you're working in the cloud, then all of the packages have already been installed and you should be fine. But either way, the library commands are written out for you here, and they're in the first chunk of the data types and visualizations exercise file. So you can go ahead now that you have that file open and run both of these lines. So this command, in terms of for looking at the data, is also written out for you in the exercises file. But let's take a look at the data together. So when you run this line, you should see the first 6 rows of the COVID testing data frame, which look like this. And just to note that this is one of the example datasets that comes built in when you install the medical data package. So it's already available to you and you don't need to download it or read it in or anything like that. So those of us, or those of you out there who are familiar with R, you know that importing data can be a really challenging and a time-consuming step, depending on the data format. So we are going to be kind of skipping over that today, but that's just in the interest of time so that we can focus on the visualization part. Okay, also, if you're interested in learning more about this data set, you can run the next line of code with the question mark, COVID testing. And this gives us some more information about this data, which is actually a de-identified data set on COVID testing that was done at CHOP. Sort of kind of cool. And if you're interested in learning even more about the COVID data and the study behind it, there is a link here that you can access. And if you're interested in learning more about the medical data R package and that these data are published in, you can see that website. And also just to call out that these maintainers are always looking for more data contributions. Okay, so we're going to get started with a quick coding challenge. So if you take a look in the data types and viz exercises, you'll see your first coding challenge there. We'll just work on this for a couple of minutes, and if you don't finish, no problem. Just pause wherever you are. And if you, on the POSIT Cloud, we do have solution files, and we'll try to take time to review the solution together at the end if we have time. If not, you can come back to those files afterwards. And if you still have questions, then that would be a great thing to bring to office hours as well. Okay, so I'll start the timer, and we'll come back in 2 minutes. Okay. In the interest of time, we'll keep moving. But again, if you have questions, feel free to hold those for the end, or you can enter them into the chat and somebody might be able to help you as well. Or you can also bring them to office hours, of course. Okay, so a quick aside, if you might have found that you were using this str function during the first coding challenge, it also can be really helpful because you can use this function on the entire COVID testing data set all at once. And the output is shown here from running that particular line of code. And this can be helpful because you'll be able to see a record for each of the 17 variables in the data set. With this set of information, there's a little bit of a preview for each one, but it's also pretty helpful in that we're able to see the data type right away for each of those. So you can see in this data set that there are a lot of character variables for which many R functions, like summary, as we talked about earlier, don't provide summary statistics. So depending on our project, we might want to consider converting some of these character vectors, for example, gender, to factors in order to get more helpful summary information when doing our data analyses. However, since that isn't the focus of today's presentation, we're just going to leave the data set as is for now. Okay, so next we're going to move on and talk about using ggplot2 for visualizations. So today we're going to start with a simple scatter plot to demonstrate some of the aspects of ggplot. The primary inputs for a ggplot figure are shown here. So you can see within the code, we have a data element, so that would be our data set, and then the data set to use for the plot, And then we also have a mapping, which is a list of aesthetic mappings to use for the plot. And kind of the simplest format for this, we most likely would want to maybe specify the x-axis variable, which here today is going to be pandemic day, and the y variable, which is going to be CT result. So if we try to print the ggplot object with only the data and mapping specified, you can see that the axes are populated, but there's no visualization generated. So in order to generate the visualization, we're going to need to add another layer in our ggplot. For example, if we wanted to create a scatter plot, we can use the geom point layer to add data points. And so here's an example where we're using that. So if we run this particular bit of code with geom point, base plot plus geom point, we can see that a scatter plot is generated. And so in addition to geom point, there are many other options, including geom line for a line graph and geom histogram for a histogram. A full list of the geom options and examples is available at the link here. And also just a quick note, depending on your R settings, you may see a warning message when you run this bit of code. And it might say something along the lines of removed 209 rows containing missing values or values outside the scale range. And this is important to pay attention to, but it's not cause for concern because there are 209 individuals who are missing the CT result variable in this data set. And so that's where that warning is coming from. Okay, so ggplot is very customizable. And so each of these geom layers has several arguments to customize colors, sizes, and shapes. So in this example, we're just going to kind of make a simple change and use the color argument to set all of the points to red. So we just are adding this one bit of information to the geom point layer. And now when we generate our scatter plot, we can see that all of the points are red. But instead of having all of the points in a single color, it may be more interesting to color the points by a different variable in the dataset. So one way to do this is to add a color argument to the first section of your ggplot code. And that's up here in this first part. This will result in points that are colored by the drive-through indicator variable. So now let me run this. You can look at the output. And you may have noticed earlier that the drive-through indicator is a binary variable, which only takes on two values, 0 or 1. And we can double check this here. I'm just checking, yes, it only takes on two values, 0 and 1. However, the legend in our scatter plot represents drive-through indicator on a continuous 0 to 1 scale. We can see that over here, rather than binary. And this is because right now, drive-through indicator is coded as a numeric variable in our dataset. So since drive-through indicator can only take on two values, it may be better to treat this variable as a factor rather than a numeric variable. So this code shows one way to quickly do this within the ggplot function. Alternatively, we could change the data type in the original dataset, but this is a quick change that will only impact the plot itself. So now you can see for the color line in line 5, we've added as.factor around drive-through indicator. And now when we run the code, we can see that the legend is now updated to only show two discrete values, 0 and 1. So next, we'll talk about changing some of the aesthetic aspects of the plot. For example, we may want to specify the colors for the points. For this particular example, this can be done by adding the scale color manual layer to the ggplot code. So that's what we have here at the bottom of our code chunk. In this set of code, we're specifying that the zeros should be colored blue, while the ones should be colored red. So now we can see that that change has been made. But of course, you might be interested in some other changes. For example, you might find that these default axis labels and default legend title, here we can see it says as.factor, drive-through indicator. Those might not be ideal, especially if you're preparing this plot for publication or presentation. So we can look into changing these on the next slide. So to make these changes and to also add a title to our figure, we can add several other ggplot layers to our code that specify the title, the axis labels, and the legend label. So here we have some code at the bottom where we can actually specify our plot title. We can change the x-axis label if we have, some preferences about capitalization or spelling, and the same thing for the y-axis. And then lastly, we can also change the legend label. So now when we run this code, we can see that our labels are starting to look a little cleaner. And as mentioned earlier, ggplot has a lot of these custom options. For example, we may want the title to be in the center of the plot, or we may want to use a different style or theme for our figure. We can change these on the next slide as well. So there are several theme options available within ggplot. And today we're just going to look at one theme by adding the theme _BW. This is sort of like a black and white theme that can be easily added or kind of replaced for your figures. And we can also make some changes like centering the figure, the plot title. So that's being done in line 16, where this is telling it to kind of move the title to the center. And we can also, for example, move the legend to the bottom if we had a preference for that. So when we run this code, we can see now the coloring is a little bit, we now are more on a black and white scale. The title is in the center, and we've now moved our legend to the bottom. Okay. And from earlier in the presentation, we talked about another advantage of ggplot, which is this facet wrap option. So suppose, and we'll talk about that a little bit more. So suppose we're interested in separating the points in our previous scatter plot based on something like patient gender. Gg's facet wrap function provides an easy way to do this because all we need to do is take our original code and add one line to the bottom. Now, when we run our set of code, we can see that we're actually going to be getting two scatter plots that are generated. The one on the left is for the female patients, and the one on the right is for the male patients. So in addition to facet wrap, there is another similar option called facet grid. And we won't get into all of the details today, but if you're interested in learning more about faceting, including the differences between these two functions, you can check out the link here. And if you're interested in exploring different ggplot themes, which are also very customizable, there's a link for that as well. Okay, now we've gotten to our second coding challenge. So we'll work on this for a couple minutes. This is definitely a little bit more involved than the previous coding challenge. So we'll take 3 minutes here. But again, if you don't finish during that time, no problem. Just pause wherever you are and we'll come back to the presentation. Okay, since time is up, we'll keep going. But again, if you have any questions or if you didn't have time to finish and you come back to it later and you're still stuck, feel free to reach out or join us at office hours. Okay. So moving on, I also wanted to provide a little bit more information about the coloring options within ggplot. So far, we have been using the Scale Color Manual option to specify colors for the scatterplot points. And this is also the option we would use if we were making a line graph and interested in specifying line color. However, ggplot also has another option called Scale Fill Manual, which is used to color fillable objects like histograms. So it's important To note that when we switch from color to fill, we will also have to slightly modify our code for the legend, as noted here. So instead of using labs with the color equals the label text, we would actually have to use labs with fill equals the label text. So this can be a little bit confusing. So next we're going to walk through an example that uses the fill options. Okay, in this next example, we are going to be making a histogram instead of a scatter plot, representing the number of patients by pandemic day. We'd like to color the bars of the histogram by patient gender. Now, instead of specifying the color option, we will need to use the fill option. So that's highlighted here. And in order to build the histogram, we are going to use the GM histogram layer. That's our second portion here. Okay, so when we run this bit of code, we see below we get a histogram with the number of patients by pandemic day, and the legend shows that they're colored by gender. And if we wanted to change the color of these histogram bars, we will now need to use the Scale Fill Manual option instead of Scale Color Manual. So that's what we're doing now in lines 10 and 11. We're now using Scale Fill Manual, and we're going to use that to set the female bars equal to light gray and the male bars equal to dark gray. And so when we run this code, we can see now that the colors have been updated. We can also customize the output using many of the same options from the previous example. So you can see here, we're looking and we're using the same sort of GG title options that we saw on the previous example. We can use XLab and YLab again to change the labels. We're also going to be using this labs argument in order to change the legend label. But note that we are now using, this needs to say fill. Unlike before, we can also use the theme underscore BW layer in order to change the plot theme to black and white. And we can center the plot title and move the legend to the bottom as we did before. Okay, so when we do this, we can now see our output looks a lot cleaner and all of the labels are there. Finally, one important thing to talk about is that you will likely need to export any figure you make so that it can be included in a presentation or a publication. The GG Save function is a convenient and very flexible way to do this. And so in the simplest way, you can actually just run this particular code right after the ggplot figure is generated or created, and then the figure will be exported to the directory of your choice. So these are sort of like the simplest kind of specifications. By default, ggplot will save your last plot. You can specify the file name that you'd like to save your plot as, and you can specify the path. Otherwise, it will go right to your working directory. And so there are a lot of options within this function about different plot specifications. So if you're working on a project, for example, for a journal that requires, a certain resolution or a certain figure size or PNG or JPEG or TIFF or PDF, whatever it should be, there are a lot of options for that within the GG Save function. And there's some more information at this link here. Okay, great. So that brings us to our final coding challenge, which we'll kind of leave as homework or something that you can practice after today's talk. And so the figure that we'll try to recreate for coding challenge 3 is shown here. And so the idea would be to try to write some of your own code in order to replicate this figure from using the COVID testing data set. And again, definitely, if you're having trouble with this, don't struggle in silence. There's so many opportunities and places for you to get help. You can ask questions and share tips, on the CHOP R Slack. You can also come to our office hours, to kind of share your progress, or if you have a particular question or error that you're getting and you're not sure why. And there's also a solution available in that same Posit Cloud sort of space in the solutions folder. So you can definitely look at that solution code. It's available, but definitely if you have kind of time and patience, you'll learn a lot more if you can try it yourself first. Okay, so now we're just going to quickly summarize what we covered today. So first, we talked about a review of the different data types that are available in R. We also talked about converting variables from one data type to another. We also talked about creating flexible scatter plots and histograms of data using ggplot. And we talked about exporting ggplot figures. And so this was a lot of information, and so definitely don't expect to remember everything, but now hopefully you have these slides and all of the example code to go back to. And I hope that this gives you just a general impression of data types and how to create visualizations in ggplot within R. And so I think going forward, this can be some really great starting code, but definitely try to utilize all of the resources and websites that are out there in order to customize the figures in the ways that you're looking to do so. Okay, and before we wrap up, we'll also just put a little shameless plug out there that if you are interested in creating some really cool figures, but it's just not something that you yourself are interested in delving into the details and the code for, and you happen to have funding for your research project, another option for you would be to be working with an experienced biostatistician or data scientist who can help you analyze and visualize your data. And if you're interested in doing that, our data science and biostatistics unit, that's our group here at CHOP. It's really our centralized service unit for biostatistics and data science analysis support. So feel free to reach out to myself or one of our other managers, Keith, if you're interested in working with us and you'd like to get some more information. Other than that, thank you all for your time. I think we finished a little bit early, so if there are questions, we'll stay on for a little bit, but also feel free to drop if you have other meetings to go to.